welcome to the next lecture on kinetics, which we have already defined earlier. We'll quickly brief that. So kinetics is a branch of mechanics that deals with motion of body with reference to cause of motion. Now here we are bothered of the forces which are causing the motion of the body. Now kinematics, we were not bothered of the forces causing the motion. We were bothered of only the motion. Wherein kinetics, so we'll be bothered of which are the forces which will cause the motion of the body. Yeah. Now in kinetics, there is one important principle you will be studying, that is D'Alembert's principle. So before understanding D'Alembert's principle, we'll quickly brief what is Newton's second law of motion, which says force is directly proportional to the acceleration, or else you can call it as, in simple terms, the rate of change of momentum on a body is directly proportional to the force applied on a body. Rate of change of momentum is very low, the force applied will be less. Rate of change of momentum is high, the force applied will be very high. It means your acceleration is directly proportional to the force applied. Therefore, which is also rewritten as, which is represented as F is equal to m into A. F being the resultant force is equal to mass into acceleration of the body. F is equal to mass into acceleration of the body. Now coming to the D'Alembert's principle, now which is based on the Newton's second law of motion, which is tried to represent in the same way. The same F is equal to ma, he tried to represent in the same way. Yeah. So now what we'll do, we'll take a body of mass m and subject it to some resultant force F, and which is having which is under motion with some acceleration A, and this is the direction of motion. Now again from Newton's second law, this can be written as what? F is equal to ma. Now as per D'Alembert's, he rewrites the same expression as F minus ma is equal to 0. The same Newton's second law is rewritten as F minus ma is equal to 0. And we already know what F is, the resultant force acting on a body, and what D'Alembert's call this expression as minus ma is an inertial force acting opposite to the direction of motion of a body. So whenever force is acting on a body, now as per Newton's law, we are already aware that a body has some resistance for the movement, which we call it as inertia. So now the D'Alembert says the same thing. So minus ma, now this itself minus ma is the inertial force or resistance force for the movement. We calls minus ma as the inertial or the resistance force for a movement acting opposite to the direction of motion of a body. If body tends to move in this direction, so minus ma is the inertial force acting within the body opposite to the direction of motion of the body. Yeah, in this case, body will be in motion, which is called as dynamic equilibrium. So you should not get confused with your static equilibrium. So when we have said earlier, when your summation fx, summation fy, when it is 0, we have called it as equilibrium, which is a static equilibrium. Here in this case, though when it is F minus ma is equal to 0, we call it as equilibrium but not static. We call it as a dynamic equilibrium, which means under such forces, that is resultant force and inertial force acting in the opposite direction of motion of the body, will not cause static equilibrium, will be under motion, will continue to move under motion, which we will call it as a condition of dynamic equilibrium. We'll take one simple problem on that. So it says an elevator being lowered into a mine shaft starts from rest, which means the initial velocity is 0 meter per second, and attains a speed of 10 meter per second, which means final velocity is 10 meter per second within 15 meter. So after traveling a distance of 15 meter from rest to, it attains a velocity of 10 meter per second. We have written down the same data here. Yeah. The elevator alone has a mass of 500 kg. The self weight of the elevator is 500 kg. You know, self weight always acts vertically downward. And it carries a box of mass 600 kg in it. Now this elevator also carries a box of mass 600 kg, and which the self weight of the box is also acting vertically downward. Now find tension in cable supporting the elevator. Now this elevator is supported by a cable, or it is hanged by a cable which is trying to lift up. which is trying to lift up or hold the elevator. So that is why when it is trying to lift up or hold up, the force in the cable will be the tension force. The force in the cable will be the tension force, which is represented by T, which you have to calculate. What is the, find tension in the cable supporting the elevator. The cable will try to lift up or pull the elevator, which we call it as the tensile force T. And also find total pressure between box and floor of the elevator. Now when this box is rested on the floor of this elevator, it will give you a reaction. So there will be a reaction from the floor of the elevator to the box. Even you are also asked to calculate the reaction from floor of the elevator to the box. Okay, I'll brief the given data again. So elevator starts from rest, which means initial velocity is 0 meter per second, and after traveling a distance of 15 meters attains a final velocity of 10 meter per second. So now, and it is held by a cable which will try to lift up or hold, and which is represented by a tensile force T, and the self weight of the elevator is given 500 kg acting downward, and weight within the box, which is 600 kg again, which is acting downward. Now this represents the free body diagram of elevator along with the box. So now, and this is the direction of motion. Downward is the direction of motion of the elevator. Now what we'll do, so now, when it is moving down, your inertial force will be acting in the upward direction. So now we'll take a very basic equation. Now these are the given data which you have already seen. So that is V square is equal to U square plus 2AS. So wherein A will be, when you substitute U is equal to 0, V is equal to 10, S is equal to 15 meter. So then you will get the value of acceleration as 3.33 meter per second square. You can substitute and cross check this value. It means the elevator along with the box is moving downward with this much acceleration. So when, as per D'Alembert's principle, we already know that your minus MA is the inertial force acting opposite to the direction of motion of the body. Now here in this case, now body is moving downward. Now inertial force will be acting in opposite direction. That would be M into A, and A will be 3.33 meter per second square. Now whatever is mass of the body into acceleration, it will be acting, will be the inertial force acting in opposite direction. That is why we have represented an additional inertial force acting in opposite direction of the motion. Now coming back to the free body diagram of elevator and box. Now we'll consider sigma. See, all forces are acting along y direction. We'll consider sigma Fy is equal to 0. That upward forces will take positive and downward forces will take them as negative. Now taking one by one. Now T already we know it is a tension force in the cable which is trying to pull up, upward force plus T. Then self weight acting downward, box elevator self weight is 500. So which is into 9.81 to convert it to Newton, and weight of the box is 600 into 9.81 to convert it to Newton. Now 500 plus 600. So now both are acting downward. We have taken them as minus. They are taken common and multiplied by 9.81. So now tension force we have accounted, self weight we have accounted, and also we know that as per D'Alembert's principle, there is an inertial force acting opposite to the direction of motion of the body, and which is calculated as what? M into A, which is calculated as M into A. And what is total M? That is 500 and 600. And what will be the acceleration with which it is moving? It is 3.33. Now it means an acceleration, an inertial force of M into A will be acting in opposite direction. So that is what we have written here, and upward direction. That is upward, we have to take it as plus. Now what are the masses? 500 and 600, and what is the acceleration it is moving with? 3.33. Now the same M into A is taken as inertial force acting opposite to the direction of motion of the body. So this we can call it as what? Inertial force. This we can call it as inertial force, which is M into A. So now equating it to 0. Now again, you should not get confused here. When we equate it to 0, it is not a case of static equilibrium. Rather, body will attain dynamic equilibrium. Body will have its motion continued which we call it as a dynamic equilibrium. Now this equation is simple. When you solve for T, so you will be getting value of T is equal to 7124.7 newtons. Yeah. So now, like sign convention, you are already familiar. When we get positive, your assumed direction of forces will be correct. If negative, your assumed direction of forces will be opposite to what we have assumed. Yeah. Now moving ahead with the next part. Yeah. Now we have calculated what now? Tension we have calculated, and you are also asked to calculate what? The pressure between box and floor of the elevator. It is nothing but what? Now your box is resting on the floor of the elevator. Now what is the floor of the elevator is doing it back to the box? It is giving you the reaction. It is giving you the reaction, which is what he has asked you to calculate. That is total pressure or reaction from floor of the elevator to the box. Now we have redrawn the free body diagram of box alone. Free body diagram of box alone. The box weight 600 into 9.81 to convert it to Newton, which is acting downward. Self weight always acting down vertically downward. And the reaction from floor of the elevator to the box is towards the box, which is upward and denoted by N1. And same time we also know that the box is also parallelly moving along with the elevator. It means it will have an inertial force acting opposite to the direction of motion of the body, which is inertial force, which is M into A. Now again, when you look at all the forces are acting along vertical direction, so we'll consider sigma Fy is equal to 0. Now one by one forces, reaction N1 acting upward, we'll take it as plus N1, and self weight acting downward minus 600 into 9.81. Why? Yeah, self weight of the box was how much? 600 kg. So downward minus 600 into 9.81. And we already know that box is under motion. Hence it is also subjected inertial force MA, which will be calculated as M is 600 into acceleration is 3.33. Acceleration will be 3.33. Now when you solve for N1, you will be getting the value as 3886.2 newtons. So you can cross check, and we can solve similar kind of problems. So now see, there is nothing change what you have done in static. So only additional thing will be, you are considering one additional force, that is inertial force, and the direction of this inertial, this minus indicates what? Not leftward and downward. So this minus indicates the inertial force acts opposite to the direction of motion of the body. This minus sign indicates the inertial force acting on the body, which is always opposite to the direction of motion of the body. Now this additional force has to be accounted while solving such problems on dynamic equilibrium or problems on D'Alembert's principle. Thank you.